So today we have Davis Vaughn, who's a software engineer at our studio and a grad of UNCC, is that right?
Yep.
Okay. Lives here in Charlotte, but yet works for our studio. And he's giving a talk today on moving averages and calendars. And you know, as you think about like other topics, like, man, that doesn't sound very sexy of moving averages and calendars. But like, I'm glad we have attendance because I was thinking about, like, what does a data scientist really do all day? It's this kind of messy stuff. It's like, it's having to think through these little hard problems. And so I think this is going to be actually an excellent talk and very practical to the real world. So, everyone, Davis Vaughn.
Thanks, everybody. And that was a great introduction because this two packages that you're going to see in this talk were very much inspired by my work in finance and the fact that this is very messy data. It's not regular time series most of the time. A lot of times you want to average things together in a ton of different ways. Maybe you want to do it relative to some kind of date column as well. And that presents a lot of different types of problems that we'll see today. So, as he said, my name is Davis Vaughn, software engineer at our studio. I work on the Tidyverse and Tidy Models team, creating lots of different packages alongside like Hadley and Max, making things like our sample and Parsnip and lots of different modeling packages. But I've also recently kind of gone like a different direction of modeling and kind of worked on other more general packages like the two that you'll see today. So 2 topics for today. The first is this things called window functions. And if you're familiar with SQL, you might be familiar with window functions. If you're not, you might be kind of a little bit confused at what that terminology means, but we'll explain. And the other is on schedules, and we'll kind of see how those 2 things can be combined together to solve some interesting problems. So if you're sitting there going, window what? And I realize now that I'm standing right in front of my slides. Then you, and never fear, they're really not that scary of a thing. This is Bank of America's stock since 2010. I just gave this talk at B of A last week, so this was relevant there. But in this red line here, you'll see kind of a 200-day moving average. A moving average is an example of an application of a window function, where in this case, just the function applied was just mean. It was the average. In SQL, it might just be AVG. The gray bands here are kind of rolling or moving standard deviations to get some kind of a Bollinger Band type idea in the finance world, where again, just the function applied is just standard deviation. So these window functions really aren't that scary of an idea. It's just the idea of some kind of sliding or moving average or moving function. Now in SQL, you are kind of limited in what you can do with window functions. There's generally, I don't know, a handful of functions that can be window functions. Average is one, standard deviation is one, kind of counting is one. But in R, like the function applied really should be able to be arbitrary. Like we like things to do whatever we want. We don't like to be constrained. So it would be great if we'd have some kind of solution for this kind of stuff that worked with any function. For example, like rolling regression. I know the LM function in base R. Maybe I want to do that in some kind of rolling way, especially for time series. That stuff is fairly relevant. The other piece of like jargon in terms of window functions that I'll have you understand before I go any further and kind of show some code is that there are 2 types of windows. One is a sliding window, and that's useful for the moving average stuff that we were just looking at. And the other is known as an expanding window, and I'll just talk about these for a second. So this is a graphic that I really like. It came from in Uber's engineering team when they gave kind of a nice little blog post about forecasting, like a nice little introduction post. But this talks about like what a sliding window is. So you can imagine in the first pass, you might have 10 days of data. So you have this fixed window size of 10. The sliding window would move forward maybe like 1 step, so then you still have 10 days of data, but instead of days 1 through 10, you have 2 through 11. So you've dropped kind of a day here on the front end. And then as you move through to this third pass, you would drop 2 days and have days 3 through 12. And this is useful for the moving averages and rolling regressions. The expanding window, on the other hand, is more like you keep all of the data and you kind of continue to grow the amount of data that you have as you move through your kind of vector or whatever. So we have 10 days of data in the first pass, and then we have days 1 through 11 in the second pass, 1 through 12, and so on. This is useful for things like cumulative sums. This is kind of the connection of how window functions work with moving averages and cumulative functions. And then it's useful for this other kind of idea called expanding window regression, where you might start with like 100 days of data and see how stable your beta parameters are by expanding that out to maybe 150 days of data and then 200 days of data and see what changes along the way. So now that you kind of have a general idea of what these things are, how do we do this in R? And this actually isn't like a new idea. The zoo package has been around for an eternity, and it has roll apply inside of it. So if you ever do any kind of like Stack Overflow searching for stuff like this, you'll immediately come up with zoo roll apply as like the solution. More recently, though, in a package that I created called TibleTime, I had this function called rollify that would take a function like mean and would return another function back to you that was kind of a rolling version of itself. I've since kind of deprecated this whole package in favor of this one called Sybil, and Sybil had kind of its own versions of this called slide and stretch, and they were kind of the inspiration of what you're going to see today. In data table, the most recent version, literally just like released last week, has F roll apply for doing kind of like a fast version of Zoo's roll apply. I haven't even gotten to like play around with this yet because it came out so recently. But today, I'm going to talk about a package for this kind of stuff called slide. Again, it builds on the work that was done in Sybil and kind of expands it out to solve a number of other problems. And by putting it in its own package, it's very lightweight and it's very useful just kind of in its own context. So how many people have used per map or lapply, either one? Okay. So the way that lapply or per map works is that it always returns a list. It kind of iterates over everything in the list, and it always returns a list. In per, you'll also have things like map double, map underscore double, and that means instead of returning a list every time, you return kind of a double vector back. The idea behind slide and the way that the functions work is very similar to per. So you have this base version that we're going to kind of play around with to just kind of understand how this works first. And then there will be some other suffixed versions like slide double and slide int that you'll see in a minute. So slide works, again, kind of like per map, where you'll start with an input vector. Here it's just 1 through 4. You'll have some kind of function that you want to apply to that input vector, different windows of that input vector. This is kind of a per maps lambda syntax. If you're not familiar with that, all this is saying to do is return the current selection. So it's just saying return .x, which is just going to be our current slice of 1 through 4. And then we've got these kind of new arguments that if you use per map you're not familiar with, and these are the ones that control the window. Before is the first one that we'll talk about, and what this is saying is I'm going to take the current element or the current position plus 2 before it, and that's going to make up my window. So when I'm in the first kind of element here, well, I'm on the current one, which is 1, and there's nothing before it, so the only value that I get here is 1. When I'm on 2, I'm on the current element, which is 2, 2 before it, well, there's only 1 before it, so let me give you that one, and those are my 2 results. And then here, this is where we get our first complete window. So you'll be on element 3, go 2 before it, you take everything between 1 and 3, and now we actually start doing that kind of sliding motion along our data. You'll have element 4, 2 before it is 2 through 4. If you're used to roll apply, you'll know that there's this partial argument there, which means that if I set partial to false, that means that I don't want any partial results. The kind of equivalent thing here in slide is complete. You set complete equals to true, and it says, don't give me any of those partial results. Don't try to compute anything there. I only want complete windows. So it will always kind of put in the missing value for any of your partial results. And when you have slide, which returns a list, the missing value is null. If this would have been slide double, you would have gotten an NA there. Another thing you might be familiar with is kind of the align parameter. So you might do center alignment by passing align equals center, that's string. Sybil slide had this as well, where they had kind of align equals left, right, center, center left, and center right. So there were just some static values of how you might want to align your output. The way that slide works is a little bit more general. We've talked about this before parameter, which is the current value plus, in this case, 1 before. After is exactly like what you'd expect. It's the current value plus 1 after. So by combining these two arguments, we can kind of do an infinitely flexible alignment parameter, where here I'm saying for center alignment, I want 1 before and 1 after. So if you look at how this is working, this is how you can kind of visualize how this is center alignment. I'm on element 2. It gives me 1 before and 1 after. So it's kind of centered around that 2 value. We talked about the expanding window as well, and that's kind of the idea of a cumulative slide. So in terms of SQL, you might do kind of before equals unbounded if you've used window functions that much. The idea in slide is just to set before equals infinite. Now I want the current value, 3, plus everything that you have before it. So it's values 1 and 2. On 4, everything before it is 1 through 3. So that's the base version, just slide, which again always returns a list. It's very useful for these kind of exploratory things. But there's also more useful ones in practical kind of settings like slide double and slide int. And there are various other ones as well that kind of cover the other kind of base types. As an example of these, imagine we just have this sales vector here. These are just simple whole numbers so that when the averages work out, they also are whole numbers. So we have 2, 4, 6, and 2 sales of some units of whatever thing. We might use slide double here on this sales vector, passing in mean as our function and saying that I want it to be the current value plus 2 before. And we end up with 2 average with itself just gives us 2. 2 and 4 give us 3. 2, 4, 6 give us 4. And 4, 6, and 2 again gives us 4. So far, nothing has really been that new. Maybe the cumulative sliding thing was kind of something extra that slides added. But the other 4 packages that you've seen that I mentioned earlier can also do all this kind of stuff. So I wanted to introduce some new things that slide can do that maybe gives it an advantage over those other packages and maybe a reason that you could use it instead. So let's try to look at a more realistic scenario. So rather than just having that sales vector just floating around by itself, it's normally tied to some kind of like date index, like the day that the sale happened. Notice that this is kind of an increasing sequence, Thursday, Friday, Tuesday, Wednesday. But it's not regular. We skipped over Saturday and Sunday. I mean, this is a business probably, so I probably didn't sell anything on Saturday and Sunday. And then on Monday, we just, in this case, happened to have no sales, so kind of nothing was logged in our database or whatever. But it could have had a value there. The question that I want to ask here is, can we do a 3-day rolling average? So this is slightly different than what we've currently been doing with kind of before equals 2 and slide double and so on. And I want to show the answer first, and we will kind of talk about how it's different and then kind of go over the solution. So with the 3-day rolling average, you might start with 829. You'd look back to 827. So your 3 days would be the 27th, the 28th, and the 29th. Again, this is kind of like a partial window idea. There's nothing before that first value. So the only one in that range is 2. Average with itself would just give me 2. Here on 830, we'd look back to 828, take everything in between. You'd have 2 values, 2 and 4. Average together give you 3. But this is where things start to get a little interesting. When I'm on Tuesday, 9-3, I should look back to 9-1. Let's ignore the fact that Saturday and Sunday are not business days right now. I'll address that later. But for now, we're just talking about a 3-day rolling average. So you look back from Tuesday to Sunday, take everything in between. Well, there's actually only one value in that range. It's 6. And then on Wednesday, 9-4, we would go back to 9-2. Again, take everything in between, get 4. So this is different than what we've been doing with slide double, because slide double has no concept of this index column. It takes a vector, sales, and looks back kind of 2 values. Or in this case, you could kind of correspond that with 2 rows. So the current row, 3 plus 2 rows before it, gives you the value for that row 3, the Tuesday values. But that's like wrong according to like the question that we're trying to answer, because we only want 9-3 to be the result in that 3rd row. So one solution to this looks like this. You can use a little bit of tidyr and dplyr magic to kind of massage this data into a form where this works. You could use expand to generate kind of the full regular sequence where we've got the index column in the top right, where now you have 8/31, 9/1, and 9/2, which were dates that were missing before. It was that Saturday, Sunday, and Monday that weren't there before. And then you could left join that with your original data to end up with just the full tibble in the top right, where we have NA values kind of logged for those sales data for that sales data column, because there's just no data there. After that, the reason that's useful is because then slide double can be used, because looking back 2 rows is equivalent to looking back 2 days. By making it regular, those things become equivalent, and then you can use slide double as before. The only tricky part is that you have to put NA remove equals true here, because in that 4, 5, and 6 row range, you had a 6, an NA, and an NA. So you really want to drop those 2 NAs and only have a 6. After you've used slide double, you would filter out for only the original dates that you were interested in, and you'd end up with this tibble in the bottom right, which is kind of the result that we wanted. Well, that's a lot. I just want a 3-day average. It's a simple question. And I had to do all this work and this like mind-bending stuff to get here. And it's not very efficient either. So imagine if you had like 200 days in between that you had to fill with NAs, or thousands. That's not really something that you probably want to do. And in my experience in finance, like you don't just do it once. Like I would have to do this thing where I'd make a regular sequence, do my moving average, filter it back down. I do a couple other stuff, and I have to do it again for a different column and do some other stuff. And you can't just do it all at once. So it becomes very inefficient to do this repeatedly. So the solution was that slide as a package needed another function. Slide should be, the function here should be kind of unaware of the index. It should look back a certain number of values. But it'd be useful to have this kind of slide index function as well that knows about an index, so that you can slide relative to this index. So .I here is going to be that date column that we had before, and then we'll see how things kind of change. So on the left here is a version with slide, and on the right here is a version with slide index. What we're going to be sliding over is just that weekday column that was just attached onto our tibble from before. And we're just going to be doing kind of a similar things that we've done previously. We're just going to be looking back with the current day and 2 days before. So we had Thursday, Friday, and then this is where things were kind of wrong for our question, Thursday, Friday, and Tuesday. For slide index, the way that this changes is that you pass in .I, an index vector, and that's going to be used to compute our windows from before and after and complete and so on. So rather than passing in before equals 2, we'll pass in this lubridate object of before equals 2 days. And what this will do is say, okay, I'm on Tuesday. It has the date for Tuesday in that index vector. I'm going to subtract 2 days from that. So that's Sunday. And now I have the 2 dates that make up my boundary, Sunday through Tuesday. And it filters out for only days that are in that Sunday through Tuesday range. That is just Tuesday. So we kind of end up with a result that actually is exactly what we want to answer our 3-day rolling average question. So you can imagine now switching out like the W day vec for the sales vector, and then instead of .f just kind of returning its input, we can switch it out for like a mean instead, and that should give us the values that we expect. So we'll do that. We'll switch out slide double for slide index double, pass through our index column, switch out the to and before for 2.Days, and this will give us our roll day column that I kind of presented earlier as the expected output. So, can we do a 3-day rolling average with slide? Yes. To be slightly or even more practical though, you might ask the question of, can we do a 3-business day rolling average? So in these, we'd like to take into account the fact that we have Saturday and Sunday off, like these are business days. And then later on, you might even consider the fact that there are holidays that your company might celebrate, that there's no way that you would have a sale on that day, so that shouldn't be considered a business day in our window. So to see how these are different, we can look at the 3-day range, looking back from our kind of problematic Tuesday date, and a 3-business day range, looking backwards. So we'll start on Tuesday, and we know that our 3-day range would incorporate the Tuesday, the Monday, and the Sunday. But the 3-business day range should really incorporate the Tuesday, the Monday, and the previous Friday, skipping over Saturday and Sunday. If you want to get super technical, 9/2, the Monday in here that's kind of missing, is Labor Day. So if that was a holiday that your company kind of celebrated, your business day range could be Tuesday, skip back to the previous Friday, and Thursday. And the solution that I'll present is flexible enough to kind of incorporate all of that logic and add your own kind of custom business holidays in if you want to. But for the purposes of like this example, we're going to ignore the fact that it's Labor Day and just use the weekend as the thing that we're trying to kind of skip over. So in terms of our solution, the 3-day average from Tuesday we know should be looking from Sunday to Tuesday. There's just one value. It's that red 6 over on the right. But the 3-business day one should be Friday, Monday, and Tuesday. So really it should be the average of 4 and 6, giving us 5. Ideally, the syntax would look something like this. When I was kind of sketching it out, like this is what I came up with, and I was like, that sounds nice. Where you just have this kind of calendar object, and it knows about weekends and holidays, whatever your custom company's holidays might be. And then you have this kind of B-days thing for business days, rather than the Labor Days object, that you could switch out and say, well, it's 2 business days, and a business day is defined by this calendar that's specific to my company. What would then happen is that whenever you did like the index minus those business days, it knows how to kind of jump over the weekend and say, well, actually my boundary starts on Friday, not Monday. So this stuff didn't exist, and it exists in other languages in various forms, especially like this type of thing, but that kind of inspired me that we needed a new package. So based on this one problem, I went out and created this package called Almanac. So Almanac is kind of a package for schedules and these things called recurrence rules, and then using this kind of bigger schedule object to adjust dates, skipping over weekends and holidays and doing all this kind of useful stuff that we saw would be useful in slide. As a little bit of jargon, just to kind of get you on the same page with me, a recurrence rule is just this kind of set of these very simple conditions that define what a weekend or a holiday is. For example, these conditions might be things like the 5th day of the month, or the 2nd Monday in the month, or the 8th day of the year. These are all these conditions are, and if you kind of group a number of them together, you come up with a kind of a set of conditions that define when a specific holiday happens, for example. As a concrete example, we can kind of define when Labor Day happens. It happens on the 1st Monday of September. So here, to create a recurrence rule, we have this base frequency of our event. Labor Day is a yearly event, so we have a yearly frequency. And then we have these recurrence conditions that you kind of tack on. Here, we recur on the month of the year, September. We recur on the day of the week, Monday, and it's the first one in the month. With this recurrence rule object, we can then start to kind of interrogate dates with it using a number of the functions inside of almanac. One of them is schedule in, which says, well, give me a vector of dates and give me a calendar, and I'll tell you if it's in that if it's in that set of days defined by the calendar or not. So here I told you 9/2 was a Labor Day, so it returns true. 9/3, kind of our problematic Tuesday, returns false. As another thing you can do, there's a schedule sequence function, which says give me a start of the range and give me an end of the range and give me the kind of schedule that defines the events that you might be looking for in the sequence of dates. And it will spit out the Labor Days between 2017 and the end of 2019. As a next level up on top of a recurrence rule, you might have kind of a collection of recurrence rules. Adding together multiple holidays or adding together a rule that defines weekends could kind of allow you to generate this larger schedule of like all the holidays in the United States every year, something like that. Or all the holidays and weekends that my business celebrates. You also have these things called required dates and exclusion dates that make this object a little bit more useful. So an example of an exclusion date is that you could have a recurrence rule where you celebrate July 4th every year, but say for whatever reason your company said, oh, in 2021 we're going to work that day. You could exclude that particular July 4th as a way to say, like, we normally recur on this except on this time. So the way that you build a schedule is hopefully fairly intuitive. You start with these recurrence rules that you just build individually. Here's one for Labor Day that we've been working with, one for Christmas, for the month of the year December and the day of the month 25, and then one for weekends where you just have a weekly base and you start recurring on weekends. This is really a shortcut for recur on weekdays, Saturday, Sunday. It's fairly simple. You then add these to this base schedule object saying schedule add recurrence rule, and you just add the 3 in with the pipe. You end up with this on weekends or kind of some holidays here calendar, but you could imagine, or schedule, but you could imagine other holidays being tacked on as well to create something even more useful. You can use this thing in schedule sequence just like before. We pass in that schedule object with our kind of date range. This is just the last quarter in 2019. And it spits out all the dates that are technically events defined by that schedule. So the 9/2 is Labor Day, the 12/25 is Christmas, and then all the other things are weekends. As some kind of other things that Almanac does, it's already prepackaged some of the holidays that are just fairly useful holidays that you kind of might expect would be easy to just kind of reach for. And it's got these larger schedule objects that are I've called calendars that are built up of just a lot of different holidays kind of prepackaged for you. So you might start with this kind of calendar US federal object, which defines a lot of the holidays that are celebrated in the United States. Add on a rule about weekends, and then you've got like a quick and dirty business calendar that would avoid all weekends and all holidays in the United States. Sure.
For let's say if you're using the calendar US federal, could you find a way just with that to cancel out certain holidays that you know you don't care? Like I'm guessing maybe that one has Halloween, so if you guys don't take off Halloween, could you from there add a little spark that says no, I don't want that?
Not yet, but someone did have like that exact question last week, so I'm probably going to add something that at least allows you to do that, remove something in some way like that. Go ahead.
Kind of a related one. So if I've got a holiday, like a date-based one, where you set up Christmas, I know you got your federal holidays anyway, but if it falls on a weekend, you would celebrate it like the following Monday.
Right.
Is there a facility to account for that type of thing?
That was a great question. I got that one last week too. So there will be, there's an observed equals true or false parameter in there. That's what that's called. It's like, If Christmas falls on a Saturday, then you observe Christmas on the previous Friday, and that's the date that your company takes off. If it falls on a Sunday, you observe it on the following Monday, and that's when your company takes off. So there will be kind of an observed equals true or false flag that you can put in this calendar object. And if you set it to true, then it would have given you the Friday before. Yeah, great question. And then the other little note here is that like almanac is fairly done except for these holiday and calendar stuff. And those will probably move to their own package just because they're kind of an extra thing on top of almanac. They don't really provide any new features as much as they're just a lot of extra really useful shortcuts. So they'll probably end up being their own thing. One reason that you would maybe use this like holiday Thanksgiving thing instead of maybe rolling your own is that these rules are actually fairly difficult if you want it to be accurate looking backwards in time. If you want it to be accurate looking forward, it's pretty easy because Thanksgiving just happens on the 4th Thursday in November. But there was a date when, Thanksgiving wasn't celebrated, like it started at some time, so you need to be accurate going backwards. And it's actually changed twice throughout history as well. So, like in 1928, there was a change of when Thanksgiving happens to stimulate the economy, just because they wanted people to go shopping. So it's just strange, like you have to deal with these human concepts, and if you have rules, if you're only interested in looking forward, it's most likely going to happen on the 4th Thursday of November for the foreseeable future. But if you actually do care about looking backwards, you should definitely just use these holiday Thanksgiving pre-made objects, which I spent a lot of time looking up when things happen and why things changed.
I don't think Easter would be really hard because that can jump around from May to
Yeah.
April and even March at times.
Easter is the hardest one by far. Yeah, it doesn't really follow a good recurrence rule. It's just kind of its own thing. But everything else always follows a nice recurrence rule. It's definitely the hardest though. Okay, so now you know a little bit about almanac. You know a little bit about building schedules and recurrence rules and these couple functions that are built into the package. And now we're going to start kind of answering some more interesting questions. So say we've got this Labor Day here. It's just a date that we already had, and it's according to our on weekends or holidays schedule. It is an event. Like Labor Day is in that set, so it is an event. And all we want to do is say, take this date and adjust it to the next business day. Like find me the next non-event date. For that, there is a function called schedule adjust, where you give it some vector of dates, you give it a schedule object, and it will kind of, by default, roll you forward one day to the next non-event date. So in this case, Labor Day was on 9/2, that was a Monday. We looked forward and saw that Tuesday was the next non-event date, so it returns Tuesday. If this would have started with Tuesday, then it would have just returned that date back because it was already not an event. So there's a third argument to this schedule adjust function that is the actual adjustment that you want to apply. By default, it's move forward one day until you find the next non-event date. But it could also look backwards as well if you want to. Here I've supplied -1 day instead, which says, okay, well, I'm on Labor Day. Basically what I'm now asking is for the previous business day instead of the next business day. So it starts on Monday, it looks back to Sunday, oh, that's a weekend, look back to Saturday, oh, that's a weekend, look back to Friday, and sees, oh, that's where I should stop. 8:30 was the previous business day. The reason that this is particularly useful as an adjustment is that it can also be a function. It's a function of the kind of problematic dates that you need to kind of do something with and the actual schedule if you wanted to supply your own. But Almanac provides a number of pre-built adjustments that are useful for a number of common conventions. As an example, if you work in finance, you might be familiar with the modified following convention. If you are a trader, for example, you might enter into an agreement with another trader and say, like, for the next 3 months, I'm going to pay you on the 15th and the last day of the month, and do that monthly. So modified following would say, well, if the 15th is a weekend, then I want the first business day after that date. So it would be like the next Monday. That would actually be when my payment date is. I would never pay you on the weekend. But if it falls in a different month, say the last day of the month was a Saturday, that's normally when I would pay you. But if I rolled forward to the next Monday, that would be a different month because I'm already on the last day of the month. If that is the case, I would do the first business day before X, so kind of just the previous business day instead. So supplying a function for an adjustment is useful in the case where the actual adjustment that needs to happen, forward or backwards, depends on the date in question. So to kind of illustrate this example, we'll use Almanac in two ways. We'll first generate the unadjusted dates of the 15th and the last day of the month, and then we'll use schedule adjust to actually adjust them to be our actual real payment dates. So here we used a monthly base recurring on the day of the month 15 and -1. This is particularly interesting because that is a very convenient way to allow us to do the last day of the month as opposed to doing something like trying to figure out what months were 31, what months had 30 days, and with February has 29 or 28. And rather than deal with all that, you're just allowed to do -1, and that would give you the last day of the month. If we use schedule sequence, then we can generate all of the unadjusted payment dates in the last kind of quarter of 2019, end up with this table here. The ones in blue need to be adjusted forward. The ones in red, 11/30, need to be adjusted backwards, in this case to the previous Friday. To solve this, we'll then have a second schedule object for the weekends. These are the things that you kind of want to step over or avoid. And then we'll pass that through to schedule adjust, passing in our dates that need adjustment. It just passes through all of them. If they don't need an adjustment, it just gets returned back as is. You pass in the things that you kind of want to avoid. That's the on-weekend events. And then you'll pass in one of the pre-made almanac functions. In this case, there's adjust modified following. There's a number of ADJ underscore something type of conventions that Almanac has provided for you. And it allows you to do kind of the correct thing. So here's the 15th, I rolled forward to the 16th. Here's the 30th, I rolled backwards to the 29th, and so on. As a final kind of question to answer before we roll back and look at what Slide and Almanac can do together and answer our original business day question, let's say that we're on the Friday before Labor Day, and rather than just kind of adjust that, because it's already not an event date, it's a business day, it's Friday, I want to actually move forward in time by a set number of business days. So in this case, I want to step forward 2 business days. I'm on Friday, and according to our on weekends and holidays schedule, which includes Labor Day, 1 business day forward should be from Friday to Saturday, Sunday. Monday was Labor Day. Tuesday is 1 business day forward. 2 business days forward would be the Wednesday. So there's a schedule step function inside of Almanac that allows you to do exactly this kind of thing. We're on the Friday before Labor Day. I want to move forward 2 business days and avoiding the weekends and the holidays. So that would end up with 9/4, which was that following Wednesday. This is really the most powerful function inside of Almanac because this is what's going to kind of give us our solution to our business day problem over in Slide. So how do we use these things together to solve that original question of how do I do a 3 business day rolling average? If you remember, ideally, I wanted it to look something like this, where we've got this kind of calendar thing that knows about weekends and holidays. We can make that with Almanac now. That's really just the schedule object that I've been talking about. And then there's this kind of B-days thing over on the right, and that still doesn't exist yet. But internally, it would use schedule step. And that's what we've seen if you were on an index and you wanted to move backwards 2 business days relative to some calendar. it's pretty easy to see how that would power this kind of business days object. Just needs a little more wiring up to make this work right. But we can still solve this problem using the functions inside of the slide package along with the functions in almanac, even though this bdays thing doesn't exist yet. But it requires learning about the third core function in slide called slide between. There are 3 core functions in the slide package. The first is just that base slide with all its kind of variants, slide double, slide end. Then there's slide index, and then there's slide between, which is kind of, you can think of it as a lower level version of slide index, where you can provide these manual starts and stops that define kind of the range each time you're kind of sliding along. So because you can think of it as maybe powering slide index, there should be a way that they're kind of equivalent. And to show how slide between works, I'll kind of show how it's equivalent to slide index, and maybe that'll give you a little intuition into how it works. With slide index, we've been looking back to days, so we'd set before equals to days 2. To see how that's equivalent in slide between, we create these starts by manually going ahead and subtracting off 2 days from our index. And then our stops is just the index itself because we're not looking forward in time at all. If I would have used after alongside before, then you would have done index plus some number of days. Then you pass these starts and stops through to kind of the corresponding parameters in slide between, rather than kind of a before and after kind of specification. That would give us the same column, this roll day column here on the right, which we've seen before. It's nothing new here. This is the 3-day rolling average, but I'm just showing how slide index and slide between can be equivalent in this regard. This line here with the starts is actually where we solve our problem. Again, if you could have done bdays 2 with a calendar, then that would have solved our problem. If we could put in bdays 2 with a calendar here and go ahead and directly subtract that from our index, that would solve our problem. We can't do that yet, but we can switch out this line for schedule step instead to manually generate those start dates. Here we've got our index. We look backwards 2 days with a -2 end value, and we'll say that our schedule is just on weekends. Maybe a little bit confusing, it could have been Labor Day as well, but for this example, remember I said we're just caring about weekends. Now that you have our starts and stops, we pass those through to slide between, and it would correctly be able to calculate that roll bday column because we looked back with schedule step. From Tuesday, we look back 2 business days, so it included Tuesday, Monday, and the previous Friday to get our roll bday answer of 5. Again, that's different from the roll 3-day answer of 6, which included Sunday, Monday, and Tuesday. So can we do a 3 business day rolling average with slide? Not by itself, but when you combine it with almanac, you can kind of get those results that you might have expected. So yes. So in conclusion, we've seen slide for window functions. We've seen slide index, which kind of supercharges it to work with more business relevant problems. You've seen almanac, which allows you to build these actual schedules and then adjust your dates relative to them. You've seen how they work together to actually allow you to do these more flexible, again, more relevant business computations. So a special thanks goes to this JavaScript library, rule, which actually internally powers a number of the kind of adjustment computations inside of almanac. And Jeroen has this V8 package, which actually allows me to call to JavaScript from R, and that's how that kind of wires that all up. James Laird Smith is a great guy who I've had a number of conversations with, and he's built this GS package, which does a number of similar things to almanac, but with a very different API at this point. We've had a number of conversations about how to merge the 2 projects together, but that's still kind of an ongoing idea. And that's all I have. So these are the 2 links for slide and almanac. If you kind of want to go check them out, I'll put the slides, again, I think you've seen it maybe somewhere along the way. The slides are on speaker deck if you want to go look at them later. But for now, are there any questions? And yeah, thank you. Sure.
Nobody else knows.
Yeah.
First of all, before I have a question, I wish this had existed like 10 years ago when I was really working on a lot of this time series and was trying to roll this myself. So the first question is when you got hired at our studio as a software engineer, did you think you'd become an expert on Thanksgiving rules?
No, not at all.
And the second one's a real question. So I'm actually working on a problem right now where I have a series of a bunch of transactions from different people, and I'm trying to figure out if it is a recurring transaction, but they could happen. The recurrence could start their monthly recurrence, but they could start at any point in the month. So mine might start on the 3rd of the month, and Ben's might start on the 8th, and Ryan's might start on the 17th. And I'm trying to find those. It seems like I should somehow be able to leverage these packages to help me do that instead of coming up with some kind of brute force technique. I don't know if you had any thoughts on.
So you're trying to figure out if it is like a recurring event?
Yeah.
Because almanac is kind of like the opposite question, right? It's like you know that it's a recurring event and you're encoding that somehow. This is like
what I've done in the past is I've just done some kind of stupid math where I'll say like, okay, I know this is monthly. There's like 8 months on here, and I see 8 transactions. Now can I go and see how those 8 transactions are occurring a month apart? But I just didn't know if there might be a way to. I know it's not the core functionality of what you build, but build the patterns in here and then try to like use it as a bit mask or something on top of my transaction and say, oh yeah, this matches.
Yeah, I mean, you could use like the schedule seek thing to go ahead and generate like what you might expect to be like, the 13th of every month, and go ahead and generate those dates and then kind of compare them, like you're saying, against your original kind of sequence of dates and see if they line up. But otherwise, there wasn't anything specific. Sorry.
I don't know, that's fine.
No problem.
I have a comment. Just you said 10 years ago. You wish this was around. About 10 years ago, when I first came to the bank, I was working with a bunch of forecasters, and to do something similar, they just created this like massive Excel spreadsheet to try to generate these rules, these binary indicators, and they would do things like Black Friday. You want to have an indicator for Black Friday when they were doing forecasting, or the Tuesday after a 3-day weekend. And so they would create all these like input variables into a model, and to try to see what would stick. But then invariably, like later, they'd figure out, oops, we made a mistake. We fat fingered one of those things,
right?
And now we need to start over. Or they would need to score the model later and produce a forecast, and they would mess up the future side of it too. So even if they got the relationships right, then botch it later. So yeah, I'm sure they would have loved this as well.
Go ahead.
So I'm wondering, do you know if anyone at Bank of America is maintaining one of these for Bank of America?
No, so 10 years ago, you wouldn't want it if they had it. So.
No.
Yeah. So first, awesome. Again, I wish I was dealing with more time series data to appreciate this right now. So the interesting thing with time series is it's very similar to spatial data. This whole idea closer is more relevant. Have you thought about taking the same idea to 2 dimensions of latitude and longitude of doing moving averages? And I'm thinking like a stream is like kind of like what almanac does, these kind of blind spots within there. And I think your framework would more or less still apply to have moving averages from the spatial dimension, and maybe it's like construction zones, or it's like certain areas you would have that almanac that says, okay, these are areas that you actually want to calculate versus some that you don't.
Could you give like a more concrete example, like with the construction stuff, like?
So maybe it's I'm thinking of like so maybe you have individual latitude longitude points, and for some of those you have like let's say precincts voting, and you ultimately want like a 1 mile radius of the moving average of the votes in those precincts. But then for whatever reason, there's sometimes restrictions. That's where like the almanac that comes in that kind of says, okay, these are ones that we don't want to, or we need to fill in because maybe it was missing data that was there.
Yeah.
But if you were to use the same thing, just thinking in 2 dimensions, you could use this for spatial data to create these moving, and not just averages, because the great thing with the map-like structure, it's any function you apply it to.
Right.
I'm just thinking, you set up the framework for this, it's just now expanding it to 2 dimensions, have some latitude, longitude points. I think your framework would work just as well for that. And I don't deal enough with spatial data, but I know there's plenty of people in the R community that might be able to think of that. So.
Yeah, I think the idea of like being able to like define where the rules are and be able to like add or subtract from that is super useful. So taking those ideas and applying them to a different, I guess, field, like you're saying, would probably be pretty transferable. Using any of the pieces in Almanac right now, they're all super date specific. So I doubt you'd be able to pull too much from it, but the general ideas would probably be pretty transferable. Yeah.
That would be really useful for migration data, like with birds.
Oh yeah, and this is where our migration across, and so that's where, again, maybe it's just talking to a few time series people to just throw out that, because it's the same idea with not time series, spatial data. Just because near means it's more relevant, same thing with time series. This is why you do moving averages. Near is more relevant.
Yeah.
So same idea, just find an interesting application, and then what I would love is not just the transparency, but then it just automatically would calculate that, so across like the United States, then to visualize what that moving average looks like, that shape, would be interesting.
That's cool. That's a good idea.
Another comment, there's no other questions, but so before I came to the bank, so over 10 years ago, I was working for a consulting company in DC, and we would do forecasting for Medicare, and this came to me because earlier in your talk you mentioned stability of the betas, and it was just kind of this like quick off the cuff thing. I don't know if you all caught it, but so anyways, going back to my story here, so we produce these forecasts for Medicare, and sometimes we'd get the forecast wrong, and they would come back and say, hey, you missed it, why were you wrong? And what we would do is we would actually estimate the model with every new data point and plot our betas over time, and saw that it shifted. So, I said I came to the bank 10 years ago, that was around the crisis time, and so we're able to see that, bond yields, that relationship that was steady quarter over quarter has now had this like dramatic shift. And so that was part of a storytelling mechanism. He's like, is your beta stable? And we had to use that same, actually, the one where the window expands at the beginning's static.
Yep.
That's the method we use to do that.
Yeah, the nice thing about like just using, like if you use like slide double or something like that, or even, it's a little bit, you could do it with roll apply, but it's a little bit harder. But using it with like slide double, like that always tries to return a double value, but like returning a list, like you could put anything in the list, right, that you're returning. So that's why it works really well with rolling regressions, because that's like an LM object that you're trying to return back. So just putting that in one slot of a list and returning that makes it super arbitrary for like you can do anything with slide. So I really like that part of it. So yeah. Okay. Thanks everybody.